All right, welcome to section 5.6, also our last section of notes for this semester. We are going to use angle bisectors and perpendicular bisectors. Now we're about to go through these definitions, but just as a reminder, what does it mean to bisect? Split something into two congruent or equal parts. Good. So if we are bisecting an angle, we're going to end up with two small congruent angles. Okay, if we are bisecting a segment, we would end up with two smaller congruent segments. And also, what does it mean to be perpendicular? Form right angles. Good. Perpendicular lines would form right angles. Anybody need more time with their objective? Okay. We'll jump into our notes. The distance from a point to a line is measured by the length of the perpendicular segment from the point to the line. So what that means is if we have a point up here and we have some line down here, if we are trying to figure out the distance from this point to this line, there are a lot of different possible paths we could take. We could take this path here and get to my line. We could take this one over here, get to the line. But the one that is defined as the distance is the one that is from the point perpendicular to that line. So this one is the only one that's considered that distance. When a point is the same distance from one line as it is from another line, the point is called equidistant from the two lines. So if it's the same distance from two different things, it is equidistant to them. Anybody need more time on this slide? Okay. A segment, ray, or line that is perpendicular to a segment at its midpoint is called a perpendicular bisector. So we are going to have some segment. We'll call this segment AB. The perpendicular bisector could be another segment, it could be a ray, or it could be a line, but it's going to intersect AB at its midpoint, so we'll call that M. This time, let's make our... that off to the side. Let's go ahead and make our perpendicular bisector a line. And we can name that line as well. We'll call the line XY. And of course, for this to be a perpendicular bisector, it would mean that this would have to form a right angle. And since M is the midpoint, which two segments are congruent to each other? AM and BM would be congruent. So we would say that line XY is the perpendicular bisector of segment AB. Questions about a perpendicular bisector? Need more time on this slide. Okay, we'll keep it moving then. The angle bisector theorem. If a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. So let's call this angle ABC. And we'll put point D in here. So if BD is an angle bisector, which two angles are congruent? If BD, ray BD, is an angle bisector, which two angles are congruent? Whoa. Let's try. One person who thinks they know, raise their hand since we're all saying letters at the same time. Sam. Good. ABD and CBD. If you were naming them in a different order, you might have still been correct if you're talking about these two little angles. So if D is on the angle bisector of it, then point D is equidistant from the two sides of the angle, meaning that DA and DC are going to be congruent. Now, my picture is not perfect, but again, these would have to be the perpendicular distances from that point to the side. So if D is on the angle bisector, then segment AD is congruent to segment DC. Those would have to be the same. Questions, concerns, need more time with this slide? Okay, so congruent angles in here, angle bisector, that makes those segments out there congruent. Oh, there it is. Okay. The perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. I'll start filling in this picture. We'll have segment LM. So there are a few things we need to know. We need to know that this line PN is a perpendicular bisector. So that means two things have to be true. If it's perpendicular, what does that mean? Right. We've got to have right angles in here. If it's a bisector, what does that mean? What's congruent? Good. LN would have to be congruent to NN. So if all of that is already true, then this point P that's on the line, that's the perpendicular bisector, is equidistant from the endpoints of the segment. So P is equidistant to L and to M. So we could draw those in. So if P is on the perpendicular bisector, then PL is congruent to PM. We could mark those as being congruent as well. Questions, concerns, need more time on that slide? Okay, we've taken in a lot of information, so let's see if we can apply it to these problems. Use the diagram to find the value of the variable. So in our first one, if these little angles in here are marked as being congruent, then what does that mean about AD? What could we call that? It's an angle bisector. So we have an angle bisector, which means this point D on the angle bisector is equidistant from the two sides of the angle. So what is the equation that I could set up? Good. X plus 1 equals 13. Those two have to be congruent if they are equidistant. So we can set them equal to each other. To solve it, we just need to subtract x equals 12. That's all there is to it. That's a lot of what today is going to be, is just figuring out what we can set equal to each other to solve. Same kind of situation on letter B. We know we have an angle bisector because those angles are congruent. H is on the angle bisector, so it's equidistant from my sides. What equation can I set up? Okay, I don't care which side the 32 goes on and the 4y goes on. Okay, but 4y should be equal to 32. To solve it, we would divide y equals 8. Questions about A or B for example 1? Okay. Go ahead and try all of these on example 2. They're just like the last example we did. Some of you may have already started on them. We'll talk about them in just a minute. All right, what was our equation for the first one on this slide? Good. So what did we get for x? Wonderful. All right, what about our equation on the second one? X minus 8 equals 35. When we solved it, we got x equals 43. Last one, what was our equation? Good. Okay, this one would take 2 steps to solve. What's the first step? Subtract 2, 3x equals 18. Then we would divide x equals, good. Okay, again, if you have an angle bisector, a point on it is equidistant from the sides. That's how we always knew these were going to be congruent to each other. Questions, concerns about example 2 problems? Okay, moving on. Example 3, use the diagram to find the value of the variable. This one is a little different in the setup. Won't really be a whole lot different in how we do it. On this one, we don't have any angle bisectors because none of our angles are marked necessarily as being congruent. We do have a perpendicular bisector because we have the right angle, so we know it's perpendicular, and we've got these congruent marks. So XZ is a perpendicular bisector. Much like when we had an angle bisector, a point on the perpendicular bisector is equidistant from the endpoints. So again, we know that these have to be congruent. So our setup does feel a lot like the last set of problems. What's our equation? Good. To solve it, our first step would be subtract 1, 7y equals 35. Last step. Divide y equals 5. Questions, concerns? Okay, Need more time? Moving right along. Okay, these set of problems are just like example 3. We have a perpendicular bisector every time, which means these points D, F, and K on these problems are equidistant from the endpoints of that segment that got bisected. Go ahead and give these ones a try, and we'll talk about them in just a minute. All right, on the first one, what equation did we set up? Good, set them equal to each other. When we divide, we get x equals 8. Questions about that one? All right, what's our equation for the middle one? Good. 2 steps to solve this one. First would be add 5, 2x equals 26. Then we would divide, x equals 13. Last one, what was our equation? Wonderful. To solve it, we would. Good, we get 6x equals. Careful on this one. What's our final answer? Somebody said it. 1/2 would be the best answer. We should simplify that 3/6 to be 1/2. Make sure, though, that you don't put 2. If you put 2, you got the whole thing wrong. Okay. Questions, concerns? This is all feeling a bit repetitive, I'm sure. Ready to keep going? All right. Back to these problems. On these problems, do we have a perpendicular bisector or an angle bisector? Angle bisector. How do you know? Good. We've got little angles marked as congruent. So these are angle bisectors. Of course, we know that means that this point H is equidistant from the 2 sides. So what is my equation? Good. These ones are a little bit more involved to solve because we have x's on both sides. So what do you want to do? Yep, we set them equal to each other. But then after that, how would we solve? Okay, we want to get all of our x's together. So one way of doing that is to subtract x on both sides. What do I still have on the left side? 3 equals x plus 1. Then our last step is to subtract 1. We get x equals 2 or 2 equals x. It does not matter to me which way you write it. Same thing. I shouldn't have boxed that in though because that's not our final answer. What did they want us to find? FH. So they don't just want x, they want FH, which means I still need to plug it back in. Does it matter which one of these I plug it into? No, because they should come out the same if we set them equal to each other. So if we are finding FH, I'll do that up here. Instead of x plus 3, I would write 2 plus 3, and that gives me 5. So that is what I should be boxing in as my answer. Questions about 5 letter A? All right, on to 5B. Again, we have an angle bisector. M is equidistant from those sides. So what is my equation? 4x equals x plus, I think that's a 15. Okay. To solve it, I need to, subtract x on both sides. What does that leave me with? Good. Last step. Divide to get x equals 5. Am I done? What do I need to do? Plug it in. They want MK. So that is 5 plus 15, which gives me 20. Of course, if you wanted to plug it into LM, you would get the same thing. Questions, concerns? Needing more time? Okay. Last problem. Do we have an angle bisector or a perpendicular bisector? Good, we have a perpendicular bisector. We see the right angle. EH and GH are both marked with 8. So we know that that is a bisector of that segment, which means that EF and GF also need to be congruent. So my equation is good. 2x plus 5 equals x plus 10. To solve it, I would... Good. We want all of our x's together. So that leaves me with what? Good. Last step. Subtract the 5x equals 5. Are we done? No, they wanted us to find EF. So we plug it in. Of course, it doesn't really matter which one you plug it into. They should be the same. 2 times 5 is 10 plus 5. EF equals 15. Final answer. We went through those examples pretty quick. Of course, they were all a similar setup. 2 different types of situations, same way to solve the problems. Do we have questions about this last set of notes? We're sure? Okay.